Hi folks, welcome to our weekly Friday afternoon online class. I want to welcome you to the Ethernet I/O setup for what we call the DVT Con IOE. It's our Ethernet I/O module that you can use to add on some extra input and output and additional functionality to your DVT system. In this section, what I'm going to do is share with you just the information about what it takes to get one of these hooked up, running, and doing what you need it to do. Primarily things like send out output signals, maybe to power on a light or a warning signal, perhaps some input signals so that you can change products or trigger the application or let the application know when it should change whatever it might be doing. So let's take a look at what components you need to be concerned with and what you should know when we talk about setting up the Ethernet I/O module for the DVT product. The first thing you should know about the product is the fact that when you use this product, you're going to need to know a little bit about the functionality and the hardware that comes with this product. Here's a picture of the product. And it's important to know what each of these items performs in order to understand what it needs in order to function properly and what you can expect in terms of what feedback it'll give to you when things are working well or when things aren't working so well and you might need to do a little bit of troubleshooting. So let's start looking at the device here, and we're going to make our way from left to right. The first one you're looking at here is actually called the DVT I/O Ethernet coupler. And what this particular one does over on the right side, all the way on the left side, is it takes care of your need to connect all of these I/O modules to the Ethernet system. So this is the way that this module actually communicates from the Ethernet network into all of the I/O that you're going to be able to power up. The next one over is also over to the right side of this DVT coupler is also going to allow you to supply power to this coupler. So not only do you get Ethernet communication on that first part of the Ethernet bus coupler, you also get power going to that system, which also works for power for all the other I/O modules that we're going to be connecting. The next one up is the Ethernet output module. Now in this image you can see that these guys are actually shown to us in a pink. And this pink value that you're seeing here allows you to know that this is actually an output module. And in this example I actually have two output modules that you're seeing here. And these two output modules are so that you can actually use the DVT system to send output signals, 24 volts coming out of those lines. And we'll get into how we configure those lines, both through the hardware and through the software in a moment. The next one down you'll find is actually our Ethernet input modules. These allow you to feed inputs 24 volts into the DVT system and have the system respond once you get those two communicating properly. So you'll see that these ones are labeled in blue, and I have two of them available to me, and these are called the input modules. Next to that, the one over, you have what we call a power in module. Now if you're familiar with the DVT system, you may already know the breakout board that we have. We call it the IBOB, the integrated breakout board. And what that board does is it allows you to have built-in I/O. Well, if you want to, you can actually use this Ethernet I/O module, this Con IOE, to serve as your breakout board as well. And what you're seeing in our next component there is actually the power in module for this breakout board, for that IBOB. And that IBOB needs to be powered in order to give power to the camera. Because if you take a look at the next portion, it's called the camera breakout board. This camera breakout board is actually going to work just like our IBOB integrated breakout board works, so that we can actually connect your normal I/O to the camera and also power the camera as well. So on this breakout board, you're going to find a couple of very important things. Number one, you're going to have all of your I/O showing up on this particular breakout module that you see here. All of these connections that you're seeing here are the inputs and outputs, and we'll talk about what each one does in just a moment. And very importantly, and sometimes something that people overlook if they already have an IBOB, is this camera connection that you see all the way to the far right-hand side. This is your camera connection. It powers the camera, and it allows you to have access to that I/O. Some folks don't connect the camera to this because they already have a breakout board, But if you want the camera to communicate using these inputs, you have to connect it here and supply power to it from here. Take a look at the rest of it. Now, connecting wires to the terminal, if you've used one of these modules or something similar to these modules, this should come pretty easily to you. You basically want to take a screwdriver, a very small one, a very thin one, and stick it into one of the modules, and it's actually a very mechanical spring that's taking care of the holding the wire in there. So you actually want to pry it so that you can see the opening come open, and then you want to stick the wire inside of it. Okay? Then take out the screwdriver, and that'll hold the wire in place. You want to make sure that the wire is being held in place by the actual lead and not the insulation, the rubber insulation around the wire. That goes without saying usually, but you just want to make sure that that is making good contact there. Beyond that, you also want to think about the following. You want to absolutely supply power to the device. So how do we do that? Well, you actually have to do that in two different places. You have to do that in the Ethernet I/O module side, okay, the component that's furthest to the left, and then you also have to look into these modules and find the power input to the breakout board component. Okay, and I see I'm showing those to you flashing here. It's pretty easy to tell them apart and also to find out where they are. The one for the Ethernet device is the one that's furthest to the left, and the one for the breakout board component is actually the one that is labeled in red, blue, and green connection and input. Let's talk about how we're going to get power to this system. So to power the Ethernet bus coupler, what you want to do is find the connections that are required on it, and these are going to be 24 volts necessary to go into those pins labeled 1.1, 1.2, and 2.2 on the bus coupler. Now, you're going to also need to supply a neutral connection to pins 1.3 and 2.3, and those are the green lines that you see detailed in this particular drawing. And what you're going to be doing is supplying power, 24 volts in fact, to these red lines that you see here, these points of connections, and that's exactly what I have done here for my power supply. In my case, I'm actually using one power supply to supply power to everything on this Con IOE, and it works just fine the way it is now. The other thing that you might be questioning is, well, it looks like I have 24 volts going to 3 places, and I only have a neutral going to 2 places on this board. That's because one of the connections for the 24 volts is internally connected to neutral, so you don't have to worry about making that connection. It's already internally shorted. So that's how you connect power to your DVT Ethernet bus coupler. The other portion of power that you have to supply is the other portion that goes to the breakout board. Take a look. You take the same 24 volt power supply, perfectly legal to do this, and you want to connect it to, the 24 volts should go to 1.2 and or 2.2 depending on the power that you need for that breakout board. The other connections are made to neutral at 1.3 and on 2.3 depending on what connections you made to the power that are needed. And these are labeled in green. The ones that get connected to 24 volts are actually going to be labeled red on that power in module, and the ones that need to be neutral are actually labeled in blue. So those are fairly easy to pick out. Now, the other thing that you also want to make sure that is something that you keep your eye on is the LEDs that are on the far left side of this DVT Ethernet coupler. Because there is one particular light there that monitors pretty much anything that could possibly go wrong when it comes to making a power connection, making a camera connection, and making communication happen properly throughout the system. And this is a light, an LED that is labeled failed. And it will either flash red with a certain frequency, or it will just go high and it will show red and show you that there is a problem with the connection or with some power. Some other areas that you want to focus in on. Well, let me show you. When you supply power to this particular module, you want to keep your eye on a couple of other places. I'll try to highlight those for you. You want to keep your eye on this area right over here, because there should be 3 LEDs that should be lit when this is working properly. One is for the source power, one is for main power, and one is for logic power, telling you that all of those components are properly powered. And if those are all properly powered, that's all set. That'll tell you right there. The other area you want to keep your eye on is this area right over here, and this is a power LED, for your breakout board component that you have here. There are two LEDs. One of them will go high when power is being supplied properly. That one is actually labeled Z. And when there is something wrong with the power, maybe not enough power, not enough of a connection, or perhaps just an incorrect connection, there is an LED labeled E, and I presume that's for error. And if that one is high, then that's where you want to try to troubleshoot some of your issues there. So those LEDs there will help you understand what's going on and where the problem happens to be, if in fact you find that you're not getting this module to behave the way you expect it to. Now, how do you connect your inputs and your outputs? Well, first of all, we need to understand where they're located, how they're labeled, and what we need to connect to them. So while this is filling in, I want to point you to first that each one of these modules, let me highlight a couple of these for you. The output modules you're seeing in pink here, put a nice big X on top of them. These output modules carry on them 4 outputs for each one of them. So if I actually have these right here that you're looking at, I have 2 modules. Technically, I have 8 total outputs. And that's exactly what you're seeing labeled here in blue. You're seeing that I actually have 1, 2 up top. Then the bottom of that particular module I label 3 and 4. And then likewise, right next to that, you see 5 and 6, 7 and 8. And because they're placed next to each other, they're going to be a continuation of the numbering system based on the leftmost output module that you're seeing here. Okay? The other components, very important to understand about the output modules and the connections that you're going to be making, are the fact that you have your neutral connections. On the output modules, I want you to notice that on the output modules, they're actually labeled green, you see here, and they're on the top portion, or the top half of the connections that you're going to be seeing on the output modules. While your ground connections, you have 4 of them, are actually on the bottom half of the output modules. Now, the other thing that I want to point out to you is that if we move over to the input modules right next to them, they have a couple of more input modules. You see them as the 2 modules on the far right of this image. You'll notice that the numbering scheme for the input modules works very similarly. We start off with the number 1, you're seeing here. We go to number 2, and then we make our way down below to number 3 and 4, and then we start back at 5, 6 up top, 7, 8, we finish off the input module. However, you should notice that the neutral connections are actually on the bottom half of the input modules. Okay? While the signal, or the 24 volts, that might be necessary to power the input properly, depending on what type of connection you're making to the input, is actually on the top. So that's just something that you want to make either a mental note or preferably a physical note, or a cheat sheet, if you will, to understand how these are configured. In fact, that's exactly what I have here next to me, because I wanted to make sure I didn't get these mixed up, and I made one for myself. So what else do we need to do? Well, if we want to connect the inputs and the outputs on the breakout board side of things, here's what you need to do. You need to know where they're located. And these are going to be configured very similarly to the previous slide that we were showing you. But these are going to be 8 general purpose inputs or outputs. They can be configured to do either one of those. So none of them are strictly outputs or inputs. You're going to configure that through the software. And that is done the same way you would have done that for the integrated breakout board that we have if you weren't using the CON IOE to connect to the I/O. Okay? So again, we have the 1, 2, 3, 4 mechanism of numbering these. Each one of these modules, as you can see, has 4 connections available to it. And then, of course, the module to the far left on this image is the actual power, where you are supplying power. Right here, I don't want to go away without showing this to you. This is your camera connection. It's the same camera connection you would see in your iBob and your integrated breakout board as well. So it's completely compatible with the same cable that you were using with your camera and the breakout board. Now, how do we get these inputs and outputs connected? Well, one of the examples I'll be showing you once we get into the software configuration of this is to connect just basically an indicator light or a signal that's going to let me know when that particular output happens to be high or when that particular output happens to be low. And as you can see, these connections are made to the output modules, right? You can see them highlighted in pink. In my application, I actually have 4 of these output modules. So what you'll see when I show you the software side of things is that you're going to start to see that I actually have a lot more inputs than, a lot more outputs than just the 8 here. I'll actually have 16 available to me. And likewise, it works the same way for my inputs because I have 4 of those modules as well. So what are we doing here? Well, if you think back to one of my previous slides, I highlighted for you that these are numbered in the following way. Okay, and I'll try to give you a quick numbering scheme here. This was number 1 here, and right next to that was number 2, okay? And down below here was number 3, and then right next to that, if you recall, was number 4. And if I take that into consideration and I want to hook up output 4 to this lamp, I want to make sure that I supply a connection from that output 4 that I just labeled to my lamp, and then take the other connection, the other part of the circuit, and complete that circuit to the neutral connection, which is highlighted here, and it's a connection being made to pin, I believe that's 2.2, if you were to look on there. Now, one thing that I ran across as I was trying to understand this as best as I could is that the numbering scheme that you're seeing here supplies very little, if any, logical label that you could try to follow. Okay, so I want you to actually look away from that particular numbering scheme and just focus on the items that we're talking about here. This is actually leftover from the manufacturer of this particular modules, or I should say of these modules. They have a default numbering scheme that they put on there. So it's probably best to look at the documentation or use this particular presentation that is available to you in order to figure out where each one of those connections are made and where they should be connected. So in my case, I've shown you how to connect an indicator lamp to output 4 here. I will do that in the real world application here that I'm about to get into. Let's talk about connecting something else. How about connecting inputs? Well, if we want to connect inputs, we want to make sure that we make that connection to the input module that you're looking at here. Again, this one is in blue, and what you're seeing here is that if I want to connect this input, which happens to be just a completion of the circuit here, okay, is going to be connected to input 2, as you can read in the slide here. I want to make sure that I connect that to input 2. And if you recall again, this was input 1, next to that was input 2, right below that would have been 3, and then next to that would have been 4. Well, if I want to make this connection to number 2, you'll notice that one of those connections is made to number 2, and the other side of that is actually connected to, I don't know if you recall, Joey, what that was right below the input 2 connection there. It was actually the 24 volts. Oh. Actually using the same 24 volts coming out of my connection here to put into my input. Let's take a jump back real quick there because I do want to show you that in action. Just missed it. There you go here. So if you take a look here, you'll see these numbers come right out. I'll clear some of these graphics for you, make it a little easier to see what's going on back there. And then you should know that the connection that I'm making here is actually to the 2.2 pin so that I can get power to go into my input on input number 2. That's where my connection is being made. I'm actually getting power right from the CON IOE and putting that into number 2. Now, you don't have to remember all of this because I will go through it and configure it with you on my software and show you how it affects the software. But I just want to show you basically what we're trying to do here. We're trying to connect that input power supply, power being supplied from the CON IOE into input number 2 here in my display. All right. Well, how do we communicate with the CON IOE? We know how to make connections to it. The next thing we need to do is we actually need to configure the CON IOE because there are a couple of things that we should know about it. First of all, one of the things that I like to do in this presentation is sort of demystify what the CON IOE is. A lot of people look at it and think it's this weird box that has a lot of connections and I don't really know how to work it. You should really think about the CON IOE as just another Ethernet device, very much like your PC is able to connect to the internet or to a network, just like the camera can connect to the network or any other Ethernet device that you might have out there. The CON IOE is very similar in that sense. It connects to a local area network. And part of something that you need in order to connect to a network is the right network configuration. So one of the things that we're going to do is get that configuration up and running here. So is an Ethernet device, meaning all communication done to it is done over Ethernet. So all of those connections that I was making just a moment ago, they're going to be communicated to the camera via Ethernet, and we're going to use a network. So let's take a look over here at some of the other things that we should know about it. In order to configure this, you could configure it to connect over a local area network, which would be simply to connect your camera, as you can see here. I want to highlight the fact that we're connecting this camera that you see here to the Ethernet hub or switch. And we're also, very important here, we need to connect the DVT CON IOE to the same switch or a hub. Okay? That's the only way those outputs are going to work and communicate with the camera, is if both of these are connected to the network. Very often, folks connect the camera up to this, connect the camera to the network, and believe that the Ethernet I/O is happening through this single connection. It isn't. If you want the Ethernet I/O to work properly, you're going to want to make that connection over on the far left side of the DVT CON IOE. Otherwise, that's a perfectly good example of when that fail light is going to come on for you. It'll tell you, I don't have communication, and that red LED will start to flash on for you. Okay? And of course, any other device, like a laptop, kind of like what I'm doing here, connected to the same network via that hub or that switch. Okay, so a couple of different connections that are very important for that communication to take place are illustrated here. If you want to make this happen over maybe your local network in your office or in the production line, you can do that as well. The only thing that you have to do is make sure that you replace that hub or switch to your corporate network. You might not be connected to just a local switch. You might have to plug into the wall. But again, you'll notice that both the DVT CON IOE and your camera and any PC that you want to communicate between the three have to be connected to this corporate network, okay, to the wall. They all have to have that network connection. Now, once you have that hardware setup complete, you're going to want to consider setting it up, that CON IOE, in order to communicate with all of these devices. Now, one of the things that you're going to want to do is use Intellect software, which is what we're going to use, or if you're using framework software, you're going to want to use what we call the ECD wizard in order to get that configured. Now, what we're going to want to do is connect to the camera and configure that CON IOE. Let me show you how that's going to happen. Before I actually do that, I want to show you this CON IOE in action, the one that I have connected, all set up, working here. I want to show you where you're going to have access to that information. So let's load up Intellect software now. And I want to show you that I'm just performing a very simple inspection here. This inspection is responsible for doing one thing. It's responsible for looking for the word pass to be in the field of view, particularly in this region that you see in blue here. Okay? Now, if that word pass is in the field of view, I am instructing my CON IOE to turn output signal for high, which happens to be connected to that light that you see there. Okay? Now, if the pass is not in the image, okay, and I'll block it in just a moment, I'm actually instructing the CON IOE to turn on output signal 2 because the application is failing. So let me show you what that's going to look like in action. I'm just going to block the word pass, and as soon as I do that, you should see that that light went off that was located under the word pass, and now the fail light has come on to designate that my inspection has failed. And the other thing I want to show you is where we're going to configure these inputs and outputs. If you look under the Communications Explorer, under DVT Ethernet I/O, you will get a listing of all of the I/O that is available to you. If you look down below here, you'll see that I have available to me digital inputs 1 through 8, digital outputs 1 through 8. And if you notice, digital output 2 is set to 1 right now, and I've configured this to have a function of fail. So whenever my application fails, that will go high. Notice what I have going on in digital output 4. This one goes high when my application passes. So very quickly, I can turn both of those outputs on or off, which happen to be connected correspondingly to my pass light and my fail light from my Con IOE. So let's go ahead and do that. I'm going to remove that particular block from the word pass there. You see that my application finds it. You should notice two things. Number one, the pass light has come on and the fail light has turned off. And number two, you'll notice that my output 4 is now high, while my output 2 is now low. They're set to track my pass and fail individually. All right, so how are we going to configure this all to work so nicely and so seamlessly here? Well, let's talk about that right now. So once we get the hardware all connected up, what we want to do is actually use the I/O configuration for your network setup. You want to assign the right settings to this Con IOE, and that's very important because, as I mentioned, this is an Ethernet device. It needs to have network configuration, things such as an IP address and a subnet mask in order to work properly. Now, how do we get this accomplished? Well, the first thing we need to do is actually load up Intellect. And once we load up Intellect, the next step is to actually connect to the camera that's going to be communicating with your Con IOE. Now, the first thing you do once you connect to the camera is head over to your System menu and open up System Communications. That's pretty much where I was showing you when I was showing my previous example. Once you head over to System Communications, you're going to be able to configure all of the details pertaining to your Con IOE. So if we make our way there, what I want you to notice is that using the System Communication Manager, you're going to be able to head into Communications, Digital I/O, and under Digital I/O, you're going to find DVT Ethernet I/O. You're going to get a nice listing, very similar to what I was showing you previously. And part of this listing also includes this area over to the right side where I want you to focus your attention. This area here tells you that you have a device that is a DVT Ethernet I/O device. You need to supply the MAC address, the IP address, and the subnet mask to this device so that you can actually communicate with it. Okay? So that is going to be our job at this point. We're going to want to set that up, and I'm going to show you how to set that up in just a moment. If you're wondering why we have to do this, it's because it is an Ethernet device. It does have to have the right IP address and subnet mask configuration for it to work. The other question that you might be asking yourself is, does this support DHCP or automatic configuration of an IP address and a subnet mask? And unfortunately, the answer to that is no. There is no DHCP support in the Con IOE. So you do have to talk to perhaps your network administrator, and if you don't have a network administrator, you just want to keep track of one IP address that you're going to use for this purpose. In my case, I'm going to set it to a particular IP address that I know that I can use on our network without any conflicts, and we're going to take care of that in just a moment. So once we have access to this, what we want to do next is click on this little area here that allows me to select the configuration for the MAC address, the IP address, and the subnet mask. We're about to configure everything we need to configure. As soon as you click on that, you'll get a dialog, and this dialog allows you to set those things up. Now, what are we going to do in order to set this up properly? Well, the first thing you need to do is to make sure that you know the MAC address of your DVT Con IOE, your Ethernet I/O module. Well, lucky for us, that is printed very legibly in the DVT Ethernet bus coupler. Okay, so it should be pretty easy to find, and I'll go ahead and check on mine when it's time for me to set that up. And once you have that, you're able to input that into the bus coupler MAC address here. The next item you're going to want to set is your bus coupler IP, and then finally your bus coupler subnet. Now, here's how it works. When you set up this dialog and you fill in the MAC address, you want to click on the Start button. And when you click on the Start button, what the Intellect software does in conjunction with the camera is it waits for that DVT Ethernet I/O module to reboot so that it can send over that configuration you just set up. Now, you do have to power cycle the CON IOE, the Ethernet I/O module. The problem that a lot of people run into is that when they try to power cycle that Ethernet I/O module, they actually cut power from the whole system. And if you cut power from the whole system, including the camera, you're going to lose communication with the camera, and the camera will never be able to supply that configuration you were trying to accomplish. So it's very important that you only cut power to the CON IOE, the Ethernet I/O module, and leave power to the camera. Otherwise, the camera won't be able to do what you're trying to get it to do. So let's jump back to just one slide. I want to show you what's happening here. First of all, you supply the MAC address of your I/O module. You supply the IP address and the subnet mask that you want to set that I/O module to, and you click Start, and that'll start the process. You'll be asked to power cycle the I/O module. Now, best way to power cycle the CON IOE is to just, well, cut power to the CON IOE. Okay? You could do that by just breaking the circuit between the power or simply disconnecting that particular module. Okay? But it must be power cut just to the CON IOE, not to the camera. Very important. We'll do that together. To set the IP address, you're going to see this. It's listening for boot P requests. That just means that the camera is waiting for the Ethernet I/O module to power up. As soon as it does, it'll look for that MAC address, and it'll set the IP address that you supply and the subnet mask that you supply. And the last thing that you want to pay attention to is the fact that this is actually something that the camera has to run, or a service that the camera has to start. And you'll notice that the state by default is stop. If you want this communication to happen, you've got to make that state be running. Okay, you've got to make it run, and I'll show you how to do that as well. But one of the very common sort of gotchas that people get into is, all right, I configured the I/O, I configured the IP address, it's all working properly, except I don't have any communication. Well, if all of the hardware is working fine and your network configuration is fine, this is definitely a place where you want to take a look to make sure that that is actually running and not stopped. We'll actually set that up ourselves as well. And finally, to start that information transfer, you want to right-click on DVT I/O and start transfer. That will put that into running mode. You will see that change from stop to starting as it attempts to start the communication, and then finally running. That's what you're looking for. Now you can change all of the functions of your I/O to do exactly what you need them to do. So let's break out from here and let's go over to the DVT interface. I want to show you how we would go about communicating and setting this up. The first place I want to go is use your application or your Intellect software the way you normally would. Set up your application, work with all the tools that you need to work with, and then let's go ahead and set this up. In this case, I'll show you that I just have one simple tool that looks for the word path to be in the scene, and it has to find at least one instance of this word path in the scene and refer it to path. If it doesn't, it's going to fail. So if I block this, you'll see that the results from my result queue there are updated, and it shows me that my application is failing. Let's take a look at how we're going to configure the I/O. I'm going to make my way over to System, Communication Settings, and under Communication Settings, it will actually pop up our System Explorer and be looking right into Communications. Under Communications, I would like you to make your way down to Digital I/O. Under Digital I/O, I want you to make your way down to DVT Ethernet I/O. And under the DVT Ethernet I/O, what you'll see is all of the inputs and outputs available to you using a CON IOE. Now, luckily, what I have here is a completely configured MAC address, IP address, and subnet mask ready to go. Well, that's because I already took the time to go through this and make sure that it was working. Well, let me do this. Let me go ahead and disable that, which will cause my state to be stopped. Okay. At this point, okay, you can't see it from where you are, but I am looking at my CON IOE, and I can tell that there's a problem, or at least that communication isn't working because my fail light just went on. Just by doing that, just by stopping that particular state, I'm able to see that fail light come on. So that right there tells you that something is not working right. If I go ahead and put this back to true, go back to running, you'll see things are working a lot nicely in my image, and my fail light has now disappeared from my Con IOE. So again, that fail light is a great place to keep your eye on to make sure things are working nicely, because as you can see, it monitors not just the hardware and power, but it also monitors the software and the communication side of things. So I'm going to disable that and make that stop. The next thing I want to show you is, suppose I came in here and this was blank. Okay? I didn't have anything configured. I just had all zeros, which is what it normally starts out with. So I'm going to set that up with all zeros here. And the next thing I'm going to do is wipe out my IP address with all zeros, because if you came here for the first time, that's what it would be. It would all be just zeros. So let's pretend we're starting from scratch here. The first place you want to go is highlight the IP address field. And when you have that highlighted, you'll see this little three-dot alliteration button that you see here. If you click on that, you will see the dialog that allows you to set up and configure the communication for your Ethernet I/O module. So let's set up the bus coupler MAC address. That MAC address is right on your DVT I/O module. Mine happens to be 00A000 Delta Alpha 89. Okay, I'm going to double check that here. 00A0 000 Delta Alpha 89. All right, looks good. The IP address that I will use is one that I already know I can use on my network, because I consulted with the folks that run our network here. So I'm going to type this in, 10.22.50.38 is the IP address that I am able to use. And one thing to keep in mind here is that not only is it important for you to use an IP address that you're allowed to use on the network that is not being used on the network, it's also very important for this IP address to have the same subnet mask as your camera, because you got to keep in mind that the communication that's going to happen between your camera and this device are going to be governed by normal Ethernet rules. And Ethernet rules dictate that in order for those two devices to communicate, IP addresses and subnets have to be configured properly, meaning within the same subnet. So there you have it. I have my MAC address in, IP address, my subnet mask in. I'll click on Start, and you'll see this event labeled Start and info saying listening for boot P request. This is basically telling me that it is now listening for that Ethernet I/O module to boot up with this MAC address so it can send this configuration that I have here. So here's what I'm going to do. I'm going to cut power to just the Con IOE, not anything else, not my camera, just the Con IOE. So I'm going to remove power to the Con IOE, and I can see that my camera will power. And we're listening for boot P requests, and I just did exactly what I asked you not to do. I accidentally removed power to the camera. So I'm going to disconnect, and we're going to try it again without losing power to the camera.
We're losing faith, Miguel.
Sorry about that, sorry about that. I just pulled the power and I go, no, I did exactly what I told them not to do. It's disconnected. Let me jump back into my camera. My camera booted up here. And as soon as my camera boots up, we will be able to jump right back in. All right, just waiting on that camera to come back up. All right, we're back in. Log back into the camera here. I'm going to try that one more time. All right, we're back in my application. Let's go up to System, communications. This is my way of showing you how important it is that you don't cut power to the camera, that you only cut power to the DVT IO module. So here we are again, got the same configuration. I'm going to head up, look at this, all zeroed out. Good, this is exactly what it would look like if we started off from scratch. Let's open that back up. I'm going to type in that MAC address one more time, 00 A000 EA89. IP address is going to be 10.12.22.50.38. And then my subnet mask will be 255.255.255.0. Let's do this again. Let's click on Start. We're listening for boot P request. I will disconnect power from my Ethernet I/O module only, not my camera. I just reconnected power to my Ethernet I/O module. And it looks like this is not responding, and I just figured out why. I'm going to stop that. I'm going to copy down the MAC address from my I/O module here. And correct that. Here we go. That is A00A045, something I should have noticed. MAC addresses are always 16 characters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 here. All right, I've got all the numbers that I need. Let's try that again. Start that. And as soon as I did that, my Con IOE was already ready to send out that boot P request, and you can see that we got boot request received from this MAC address. As soon as I fixed that, that worked great. Boot P reply sent. We sent 10.22.50.38 IP address and a subnet mask, as you can see here. Stop, server is idle. It's ready. It's configured. So I'll click OK. But before I do that, I want to show you one more time. We need to supply the correct MAC address, the correct IP address and subnet mask. Click on Start, and we're going to get a connection from that particular module immediately if it's ready to boot. All right, so what do we need to do now? We'll click OK here, and you'll notice that all of my communication settings are under the bus coupler heading, working the way they're supposed to work. And the next step would be to make sure that we have this set to true so that we have this running. And as soon as I do that, I hope that you notice that my pass light started to go on here, as you can see here. And you can monitor my output here. You can see that its state is 1. Okay. You can also monitor my output 2 here. Okay. And if I make this particular application fail, you'll see that output 2 now goes high, and that light goes on under my camera. That's what you're seeing there. Now, what else could we do with this? Well, one other thing that I showed you that we were going to do is we were going to make a connection to digital input 2. And if you take a look at this digital input 2, I have set the function to be trigger. And with the trigger function, that tells me that input 2 on the DVT-IO module is actually going to control when my camera is triggered. Now that can be to a photo eye, that can be to really any device that can generate that signal and tell the camera to acquire an image. In my case, I just have 24 volts going right back into that particular input. So here's what I'm going to do. I'm going to show you that right now I have a live image. So if I, pass my hand in front of the camera or block the scene, it's just a live image constantly updating. My lights are turning on and off depending on whether or not I have the word pass in the field of view. Well, here's what I'm going to do. I'm going to set my external trigger on, and that will stop the slab acquisition. There are no images being acquired now because the system is waiting for an input. Okay? And I have configured that input to be digital input 2. So let's go ahead and trigger that. I'm going to go ahead and push on my button here. I want you to notice 2 things. I want you to notice that the image appears not to have changed because I haven't changed anything in the scene. But can you take a look at input 2? Can you see the value of input 2? That is now 1. If I release that button, you'll see that that is now a 0. So let me change up that image, and then I'll go ahead and send the trigger using my button. There you go. So now, using my input from that I/O module, I am triggering the camera for the acquisition. The acquisition is showing me that the image has changed, and the light designating pass is off, and the light designating fill is on. One last thing that we also want to always communicate to folks that are planning on using this CON IOE is that the communication that you make happen through the Ethernet is going to be limited in terms of speed to whatever Ethernet speed you have access to. So it is not something that we recommend you use in order to trigger a camera in a high-speed application or provide a strobed acquisition to a camera, because there is a significant delay when it comes to those kinds of functions. Okay? You might find that in a situation where you can set this up in your own company-wide network and it seems to be working fine, if there is any stress put on that network, maybe people are checking their emails at lunchtime, or a couple of people are streaming video, I don't know, that is going to affect the speed at which this communication can happen. So it is something to consider. It should really be used primarily for such things as warning systems, turning on a signal or communicating to a PLC that something has gone wrong, or perhaps product selection is another very, very popular application for the CON IOE, because a lot of folks are already using up the 8 inputs and outputs on the breakout board, and they find that they still need some more inputs and outputs. They pick up one of these guys, and they can be used very successfully for product selection, something that isn't so time critical. All right, folks, that wraps up what I wanted to display to you regarding the CON IOE. Wondering if you have any questions I might be able to answer for you, or any examples that you might have in mind of where one of these guys might come in handy for you.
I don't think you have enough time for all the questions that I have, Miguel.
Is that right?
No, I'm just kidding.
Oh, okay.
One question Jet had was, he heard that there was a new CON IOE product coming out. Do you know anything about that?
Yeah, absolutely. Yeah, that is correct. This particular model that we're talking about here is actually no longer sold. So you won't be able to pick this particular model up, but what you will have is a replacement for it. And I actually have some details about it here. The channel bulletin will actually be going out next week. So
okay.
One of the reasons why we wanted to make sure this was covered and also recorded. But to share with you some of those details, it's going to be made by a corporation by the name of Wago. And it's going to provide flexible I/O. It's going to include 8 Ethernet inputs and 8 Ethernet outputs available to you. And it's going to happen over Modbus. Communication is actually going to happen over Modbus. That's going to be called the CON DVT IOE. It's going to be the part name for that.
Can you say that again about the Modbus? How that's going to communicate?
It's going to actually communicate over Modbus TCP instead of just plain Ethernet. All that stuff is actually going to be very transparent to you, because you're going to still continue to set it up in a very similar fashion. But it's actually going to be using Modbus in the background. And by adding additional modules to this particular model that's going to be released, you could have potentially up to 128 I/O points in that particular version.
Miguel, on your presentation here,
Yeah.
you had a lot of animation.
Yeah.
Particularly pertaining to the diagrams and the X's and all that kind of stuff.
Yeah.
Can you make this presentation?
There's actually a couple of levels of the presentation that you got a chance to see. The presentation itself is animated very well by a gentleman by the name of Nick Wiegand here at the office. But where you saw X's pop in and pop out and check marks, that stuff I was doing as I was teaching it. If you're interested in seeing that, a replay of that, or being able to see that again, this is being recorded and it will be available for download on Monday morning.
Now, do you do that animation through the Microsoft Live?
Yes, I did that animation, the check boxes and the X's and the text that I was throwing in there for you. That was all done through Microsoft Live Meeting, correct? Like these guys right here. See these arrows that you're seeing here? The blue arrow is Microsoft Live Meeting. The red one is actually being done through PowerPoint, and that was all done by Nick Wiegand.
Okay, yeah, I might have to, because I've been talking to a guy at Microsoft about maybe doing the meeting thing.
Yeah.
Possibly doing some of these things for our customers or whatever if I need to do a little presentation. I'm just wondering how you did that. So I might get in contact with Nick next week just to see how he did that stuff.
Yeah, the everything that you're seeing, let me see. You know what I can do? I can actually clear out what I did right here. There you go. So everything that you're seeing there, Nick, the additional arrows and check boxes, stuff like that, that kept popping in, that was all done through Live Meeting. The other stuff was done through PowerPoint.
All right, I'll need to get a demo of that through them.
Sure. If you also want to see some of the other functionality of Live Meeting, if you're interested in going that route, all of our classes done in the past 2 years have been done in Live Meeting. So if you take a look at the download section of our website, all the videos for Insight and the latest in DVT are all done in Microsoft Live Meeting, and when it plays back, it shows you everything that is Live Meeting.
And when you archive these presentations, where do you use that data storage? Is that through Live or is that through your own website?
No, that's through our own website, although Live actually allows you to store it on their servers if you want to as well, but we use our own storage. We get it off of their site and we post it up on our site.
All right, Miguel, I think that's all the questions that we had for today, and I really appreciate the time and the presentation.
No problem at all. Glad I was able to use it and help you guys.
Any updates on the Con IOE DVT? I'm assuming you'll have another one of these.
Yeah, exactly. As soon as we have more details about that and we can get one in our hands, we'll put one of those up as well. And maybe we can get Nick to update his presentation here to go along with that as well.
Yeah, well, I got a quick question then.
Sure.
Isn't this the current, or whatever you want to call this, past Con IOE? It was expandable, wasn't it?
It was.
And so is the new one going to be expandable as well?
Yeah. The new one is going to be expandable up to 128 I/O points.
Okay. I guess that's all I have.
Yeah. And I want to show you actually one more thing that is very relevant to this Con IOE and the way it works. When you make a connection to it, let's see if I can get a shot of the whole thing here. When you make a connection to it, you have to understand a little bit about what's going on in the background or in the backplane of these connections and these modules. And the reason I say that is because if you look at the whole module as you're seeing here, anytime you drop in one of these guys, okay, it severs any power connection between to the left of it and what's to the right of it. So a lot of times what folks run into is that they'll supply a network connection over to the far left. They'll supply power everywhere they need to supply power here to the bus coupler and all of the input and output modules on the Ethernet I/O modules, but they won't supply power to the breakout board side, and the camera won't be getting power. And a lot of people assume that because they're right next to each other, this one of these power connections will power the entire thing. Well, if you throw this power in module here, it completely separates that power backplane from the rest of the DVT IO module here.
Okay.
So even though they're linked up, they are acting as separate power backplanes there.
Yeah.
And the LEDs that you see on top of here, they're all live, they're all active. They'll tell you when the output is on or when the input is high for all of those IO points that you see there. All right, guys, thanks for coming. And if you want to check this out again or pass it on to the other folks that might be at your facility or your customers, it'll be available for download on Monday, at which time I will also, do a little Hollywood processing so that it doesn't show up the cutting camera power as well.
Okay. we'll look forward to the editing.
Sounds good.
All right, Miguel. Thanks again, and thanks for calling and reminding me, man.
No problem, guys. Take care.
All right. See you later. Have a good weekend.
You too. Bye-bye.
The moderator has disconnected. At this time, the conference will be terminated.